Hello everyone. Welcome back to the Daily LeetCode channel. Today's LeetCode Daily challenge problem is 1895, largest magic square. Let's understand the problem statement clearly. A k by k magic square is a square grid filled with integers where the sum of every row is the same, the sum of every column is the same, and the sums of both diagonals are also equal. Important point. The numbers inside the magic square do not need to be distinct. Also, any 1x1 grid is considered a magic square by default. Now, you are given an m by n integer grid. Your task is to find the largest magic square that exists inside this grid and return its size, which means the side length k of that magic square. In simple words, you need to search the grid and figure out the biggest possible square subgrid, where all rows, columns, and both diagonals have the same sum. That's the problem statement for LeetCode 1895, largest magic square. Let's now move on to understanding the approach and solution. Now let's look at example 1 to understand the problem better. We are given the grid. 2D array of 7, 1, 4, 5, 6, 2, 5, 1, 6, 4, 1, 5, 4, 3, 2, 1, 2, 7, 3, 4. The output for this input is 3. This means the largest magic square we can find inside this grid has a side length of 3. Let's see why. Inside this grid, there exists a 3x3 magic square where all row sums, column sums, and diagonal sums are equal. In this magic square, the common sum is 12. First, let's check the row sums. 5 plus 1 plus 6 equals 12. 5 plus 4 plus 3 equals 12. 2 plus 7 plus 3 equals 12. Next, the column sums. 5 plus 5 plus 2 equals 12. 1 plus 4 plus 7 equals 12. 6 plus 3 plus 3 equals 12. Finally, the diagonal sums. 5 plus 4 plus 3 equals 12. 6 plus 4 plus 2 equals 12. Since all rows, columns, and both diagonals have the same sum, this forms a valid magic square. So, the largest magic square found in this grid has a size of 3, which is the final answer. Now let's look at example 2. We are given the grid. 2D array of 5, 1, 3, 1, 9, 3, 3, 1, 1, 3, 3, 8. The output for this input is 2. This tells us that the largest magic square inside this grid has a side length of 2. Let's understand why. In this grid, we cannot form any 3x3 magic square because the row sums, column sums, and diagonal sums do not match. However, there exists a 2x2 magic square that satisfies the magic square conditions. For a 2x2 square, the sums of both rows are equal. The sums of both columns are equal. And the sums of both diagonals are also equal. Since a valid 2x2 magic square exists and no larger magic square can be formed, the final answer is 2. That's why the output for example 2 is 2. Now let's move on to the solution approach for this problem. High-level idea. The goal is to find the largest square subgrid where all row sums are equal, all column sums are equal, both diagonal sums are equal. To do this efficiently, we use prefix sum so we can calculate row and column sums in constant time. Step 1. Grid size. Rows, cols equals len, grid, 0. Rows is number of rows in the grid. Cols is number of columns in the grid. Step 2. Prefix sum arrays. We create 2 helper arrays. Row prefix, col prefix. Why prefix sums? Without prefix sums, calculating row or column sums repeatedly would be slow. With prefix sums, we can get any row or column sum in one time. Row prefix sum. Row prefix R, C equals row prefix R, C, 1 plus grid R, C. Stores cumulative sum of each row. Helps us quickly calculate the sum of a row segment. Column prefix sum. Col prefix R, C equals col prefix R, 1, C plus grid R, C. Stores cumulative sum of each column. Helps us quickly calculate the sum of a column segment. Step 3. Checking if a square is magic. Def is magic square, start row, start col, size. This function checks whether a square of given size starting at start row, start col is a magic square. Row check. Take the first row's sum as target sum. Ensure all other rows match this sum. Column check. Ensure every column sum equals target sum. Diagonal checks. Check main diagonal. Check anti-diagonal. If any check fails, it's not a magic square. Step 4. Try all possible squares. For R in range, rows. For C in range, cols. Try every cell as a top left corner. From there, try the largest possible square size first. Why largest first? Because once we find a valid magic square, smaller ones don't matter. Step 5. Track the largest size. Max size equals 1. Minimum answer is always 1, since 1 times 1 is always magic. Update max size whenever a bigger magic square is found. Alright, now that we've implemented the solution, let's go ahead and run the code. As you can see, all the test cases are passing successfully. No errors, no issues. Now, let's submit the solution. And there we go, accepted. Our solution correctly finds the largest magic square using prefix sums and efficient checks. That brings us to the end of today's LeetCode Daily Challenge, Largest Magic Square. If you found this explanation helpful, don't forget to like the video, share it with your friends, and subscribe to the channel for more daily LeetCode solutions. Drop a comment below if you'd like a simpler explanation, a different approach, or solutions in Python, Java, or C++. Thanks for watching, and I'll see you in the next problem. Happy coding!